Assalamualaikum, good day. My name is Faizal Abdullah. I would like to present my paper titled A Strategic Decision. Assalamualaikum and good day. My name is Faizal. I would like to present my paper titled Strategic RCM Decision Analysis Model using Fuzzy and HP for Refinery Critical Valve. My paper ID is 26. A little bit background about myself. My name is Faizal bin Abdullah. Currently working as a package manager for Instrument Control and Telecom for Qatar NFPS project, and the company name is ICEBM Rehat. I am currently engineering doctorate candidate in Razak School of Technologies. My supervisor is Associate Professor IR Dr. Muhammad Khairi Hussein from Razak Faculty of Technology and Informatics. Okay, the outline of my presentation. First, it will be introduction, problem statement, objective, summary of literature review, methodology, proposed system model, conclusion, and reference. Okay, introduction. Reliability and availability are one of the key aspects for cost optimization. A typical process plant has hundreds of or thousands of control valves, depend on capacity of the process as a system. A valve is a critical instrument, which is a device that highly engineered equipment that serve as a control element in process plant. When we say process plant, is including refineries, petrochemicals, for example, chemical processing plant, oleochemicals. This is what we call process plant. Failure of control valve might lead to a safety incident, environmental incident, financial loss, and performance or efficiency drop. Why? Because mostly process plant is a hazardous manufacturing industries, which is failure of one single element might cause a very catastrophic incidents. This is an example of catastrophic incident that happened recently. The first one is explosion and fire in the ExxonMobil Torrance refinery in California in 2015. The root cause is a valve failure, which is the passing or internal leak of the valve based on the CSB report in 2019. And the second one that related to valve failure is a BP Texas refinery explosion accidents, killing 15, injuring 180, and resulting in financial loss about 1.5 billion USD in 2005. And the root cause is a simple control valve malfunction in that refineries. Due to large population of control valve in the process, cost of maintenance also very high. So there are requirements to optimize the maintenance strategy for this valve. For this valve manufacturing for refineries. Okay, problem statements. Recent studies, there are many studies mentioned about the lack of critical assessment system, which is there are a few problems. The first one is the lack of risk factor considered. Okay, when we say the lack of risk factor, meaning that there are only a few risk factors that consider in order to determine the maintenance strategy and the criticality of the valve or equipments in the process industry. So Liu in 2013 has a very detailed literature review paper, which is concluded that the mostly the papers only consider the severity of the risk and or probability that happen for the maintenance critical analysis. Kermani in 2016 proposed that a maintenance strategy must combine with a strategic decision for comprehension, or better comprehension and analysis. And Braglia and Bevilacqua in 2000 mentioned that for the multi-criteria decision making for maintenance strategy, most of the papers only address in linguistic term for critical assessment and maintenance strategy selection. However, there are few that consider a strategic concern in maintenance management. Okay, the second problem statement is criticality assessment analysis. Okay, traditionally failure mode and effect analysis, or this is part of RCM analysis, which is In industries, in research, this is the traditional method where how we determine the criticality of any equipment. For example, we have thousands of valves. How are we going to determine which valve is the most critical, which valve is the least critical? So by using the RPN number. RPN number is the result of multiplication of three risk factors: probability, severity, and detectability of failure. Or we call it RPN equal to P times S times T. So many researchers saying that this traditional FMA analysis may result the same value RPN in respective of the degree of importance. For example, if probability is very high but the detectability is very low, we might result the same thing as probability is very low and detectability is very high. So meaning that we don't know which when we want to have a more priority on probability and severity, we might get the same number if the detectability is high and both probability and severity is low. Okay, so Gupta in 2017 also mentioned that traditional critical assessment criticized for several reasons. One of it is not represent the actual risk level, meaning that a different risk level might result the same RPN number, then the maintenance strategy will treat this as a same criticality. So many authors related to research agreed that conventional method of using RPN conventional method do not represent the true picture of associated risk of the equipment in criticality analysis. The third one is a maintenance strategy selection analysis. Baby Aqua and Braglia in 2000 mentioned that the second problem to define the best maintenance strategy for each group is based on the criticality, based on the expert quality assessment. Gaba et al. In 2003 mentioned that maintenance strategy selection and process involve non-engineering factors in the maintenance decision problem. Non-engineering means that this is based on biased decision from the experts. Deshpande and Modak in 2002 mentioned that RCM methodology is the logic tree decision used in selection of appropriate maintenance strategy, which basically based on only two major decisions, which is applicability and effectiveness. So it's not represent the strategic concern of maintenance. Okay, now we go to the objective of this research. This research we outline three objectives. The first one is to investigate the risk factor required to be considered for valve maintenance strategy from a strategic perspective, to propose a strategic decision-making analysis using multiple criteria for refinery valve, and the last one is to validate the proposed decision-making model by implement to the existing case study and feedback from industry experts. Okay, now we go to the literature review. The first one, we're going a little bit introduction about the refineries. Refinery is a plant or petrol refinery plant that convert crude oil into other liquids, which is a petroleum-based product. For example, gasoline, diesel fuel, heating oil, fuel oil, asphalt, LPGs. Petroleum refinery produce liquids to the petrochemical industry used to make a variety of chemical and plastics, for example. To survive, refineries operator must strive continually to improve performance and reach reliability, and subsequently to gain more profit, especially during the after the economic downturn and due to COVID-19, and this has a very big impact to the refinery industries. Then next one is to increase the equipment facilities, reliability, and improve production performance, efficiencies, and product quality. Okay, a little bit summary about the valve. A study has been done for the valve using the catalogs, manuals, journals, technical manuals, and industries publications. And then this is the summary of valve maintenance consideration that we need to taking care when we want to do the valve maintenance, from the valve function, valve functional failure, valve failure mode, valve failure cause, valve failure impact, valve failure pattern, valve failure detectability type, maintenance strategy selection, and maintenance consideration. Okay, maintenance, strategic maintenance. Strategic maintenance is a crucial aspect of maintenance management that plays a significant role in ensuring effectiveness and efficiencies of maintenance activities. Sung in 2002 discussed 4 strategic dimensions of maintenance management, but study did not discuss the challenge of criticality assessment method as a strategic concept for maintenance management. There are 4 dimensions proposed by Kaplan and Norton in 2001 for strategic management, which are financial, customer, internal business perspective, and learning and growth. Kermani in 2016 proposed a strategic decision-making analysis model for the oil and gas equipment maintenance and asset management, which helps to select a critical equipment and deciding on the maintenance strategies. This model is based on artificial intelligence and MCDM, multi-criteria decision-making techniques such as fuzzy logic and AHP. So this model will be adopted in this research to proceed with the refinery valve specific maintenance strategy that will be used in the research. Okay, background about the RCM, reliability centered maintenance. Okay, there are 2 critical factors, critical success factor for RCM, which is the first one is equipment criticality assessment and maintenance strategy selection. There are many standards about RCM depending on industries. For example, oil and gas, they have their own RCM guidelines. Aviation have their own RCM guideline. Nuclear plant have their own RCM guideline. So all the guidelines mostly cover how we going to perform the RCM process. Most of them have these two critical success factor, which is the criticality assessment and maintenance strategy selection. From the literature review, we have studied about 50 selected papers that are related to this research, which is RCM analysis related. About the contribution of papers, 43% is applications or applicative type of papers, 25% is theoretical, and 32% is methodological. The focus of the papers that have been studied in this research, 72% is industrial focus, 24% is focused on plant manufacturing process, and only 4% focus on equipment. So this paper will be this research, my research will be focused on the refinery valve, which is considered as an equipment focus. Okay, in terms of strategic strategic perspective consideration, only 23% consider all perspective or strategic perspective as proposed by Kermani. 77% only consider 3 or less which is the conventional risk factors. Okay, and then in terms of 4 strategic perspective, safety only 10 over 50 or over 30 plus paper consider safety perspective. Only 15 over 47 papers discuss about financial perspective. On less than 5 discuss about the operational perspective, and about balance 20 plus discuss about technical perspective. Meaning that there are some perspective is not really considered by the researchers in terms of maintenance consideration. In terms of methodology framework, 72% of the researchers using fuzzy base as their core or method of analysis for criticality analysis and maintenance strategy selection. Okay, now we move to the methodology of this research. Okay, the first step of the research is to determine the strategic valve maintenance risk factor. The second one, the first one model is to develop a fuzzy logic critical assessment model for refinery valve based on the valve risk factor determined in the step 1. And then the last one is a phase 2 model, which is AHP maintenance strategy using risk factor and criteria of selection. Okay. A survey was designed to determine the 8 most important risk factors of the refinery valve using the weight of importance ranking. 5 experts was interviewed and survey from the refinery is used to weigh in the variable assess to assess the importance of each risk factor for the critical refinery valve. The rating of this risk factor against was evaluated by the expert as shown in the table. Okay, so based on this, we only select 8 the most critical factors for the valve, and these 8 will be used as the uh, important risk factor for the next critical analysis model. What's the 8 risk factor that determined in the previous survey was divided into 4 perspectives, 4 strategic perspective, which is adapted from the Kermani model. The 4th perspective is financial, which is the maintenance cost and production loss. Safety and environment perspective, which is safety and environment impact. Technical perspective, which is the hidden failure and failure pattern. And operational perspective, which is the process at stream level, and then the failure rate. Using the fuzzy logic, the MATLAB fuzzy logic toolbox has been used in this research. A rule-based fuzzy logic rule-based table has been developed by using the for each branch of the strategic perspective, and then it was inputted into the MATLAB fuzzy toolbox. Okay. The rules, the creator is based on the balance risk matrix. For example, the financial perspective, maintenance cost high and production loss is high, then the result of this fuzzy is very high critical, for example. So this is the fuzzy surface for each branch of the strategic perspective has been created in the MATLAB fuzzy logic toolbox. This is the summarize of the table of the rule base fuzzy rule base. Okay, this is the surface fuzzy surface result from each perspective of the strategic model. Okay, the second phase is to develop a AHP-based maintenance strategy selection based on the risk criteria or 8 risk criteria that we have selected in the previous one, which is from the safety impact, and whether impact, hidden failure, failure pattern, severity of process, failure rate, production loss, and maintenance costs. And the strategic maintenance tasks or maintenance strategies, whether preventive maintenance, condition-based monitoring, failure findings, and reactive or run to failure. 3 experts has been interviewed and participate in the HP model input interview to evaluate the weight of each risk factor and select the best maintenance strategy for each factor. And the result of this survey based on the AHP input is presented in that table, which is safety is the rank of the highest critical risk factor, and then failure pattern is the least critical failure factor. Each of the failure factor has been prioritized. Okay, and then this is the graph showing that the percentage or relative percentage of the priority means. Based on the HP results, this is the SDM RCM model that has been developed, combining the phase 1 and phase 2 model, which is the fuzzy rule-based method for the first model and AHP selection model for the second model. And each of the risk factor has been proposed with different strategic maintenance or different maintenance strategy. For example, the safety impact must use failure findings. Environmental impact also use failure finding. High production downtime use preventive maintenance. Same to high failure rate use the preventive maintenance. So this is the model that we name it as a SDM RCM, Strategic Decision Making Analysis for Refinery Valve. Okay, So the conclusion of this model, the proposed SDM RCM model suggests that the model will be able to overcome the deficiencies of traditional critical assessment technique that rely only on two conventional risk factors. The expert judgment used as input to evaluate risk criteria and select the most suitable maintenance strategy using the HP method. And this has been suggests that will overcome the maintenance strategy selection problem. The next phase of this research is to validate the model using the case study and feedback from the experts. Thank you so much for my, that's all for my presentation. So now it's open for the question and answer. Thank you.